So the first function we're going to take a look at graphing is f of x equals x cubed plus 2x squared minus 24x. So I've got steps broken down here for each piece that we're going to take a look at. So as a reminder, to find the degree of the function, we look at the highest power, and then the name of the function is based off of the degree. So the highest power is 3, which means it is cubic. Second piece, for the shape of the function and the end behavior, we will use the chart that I gave you in the vocab and the leading coefficient. What I would like you to do for shape or end behavior is to sketch which way the graph will be facing. So because our lead coefficient is positive, our cubic function will start down and open up. So that's what I'm looking for, is just a little sketch. And what that will do is when you put all of your information together in your graph, if it doesn't match this little sketch that we have here, as far as especially the end behavior, that it starts down and heads up, then you need to go back and find your mistake. It may have been you mistakenly wrote down the wrong shape or end behavior, but it could be that you made a mistake with something when you were graphing. In any case, if they don't match, find your mistake. All right, so the next is the y-intercept. Remember, for our y-intercept, we're going to substitute 0 into our function. So we will evaluate our function at 0. And 0 plus 0 minus 0 is 0. So our y-intercept is the origin. For our x-intercept, we set our function equal to 0 and factor to solve. So the first thing I notice is we have a GCF. So I'm going to factor out the x. And then what I have inside my parentheses is a quadratic. Lead coefficient is 1, so I can use my t-chart method. What multiplies to negative 24 and adds to positive 2. And that would be x minus 4, x plus 6. So setting each piece equal to 0, we have 3 zeros for this function. X equals 0, x equals 4, and x equals negative 6. None of them are repeated, so the multiplicity of each 0 is 1, which means when we sketch our graph, it will cross the x-axis at each of these zeros, as opposed to the 0 being a turning point. Remember, if the multiplicity is even, the 0 is a turning point for the function. All right. Step 3, we're going to look for turning points between the x-intercepts. So remember, if our graph is crossing the x-axis at each of these places, at some point it has to turn to go back towards the x-axis to cross it again. So all of our turning points will occur between our x-intercepts. And I'm not looking for you to be 100% accurate on this. We're just going to check the integers between our x-intercepts and find our turning point that way. So we're going to make a table of values. And our first two turning points going in numeric order are negative 6 and 0. Sorry, our two zeros are negative 6 and 0, so our turning point has to occur between those. So we're going to check, again, just the integers between those two zeros. And once you see the numbers change direction, then you can stop. You don't have to substitute all of these back in. I already did that, so what I'm doing with my x equals negative 5 is I'm substituting it back into the function to find the value at negative 5, and I got 45. The value of the function at negative 4 is 64, so our value is going up. The value of the function at negative 3 is 63, so it started to come back down. So that means negative 4, 64 is our turning point. So we don't have to check the other two. It's going to keep going back down to cross the x-axis at 0. Now we have to find our other turning point. So we're going to list the values between 0 and 4. And again, substitute these into the function to find the value of the function. At 1, it is negative 21. At 2, it's negative 32. And at 3, it's negative 27. So here our value was decreasing until 2, and then it started to increase again to go back up to cross the x-axis at 4. And if that doesn't make sense, when I graph this, and show you these turning points, you will see what it is that we just found in part C here. And then finally, we're going to plot all of the points that we found, put them all together on a graph. The reason I didn't already have a graph here is because you can see our turning points are at -32 and +64. So when we sketch, we might scale our axes quite a bit differently. So, in order to get up to 64 for one of my turning points, I decided to scale my y-axis by 8. And then my x-intercepts were relatively normal numbers, -6 to 4, so I just scaled my x-axis by 1s. All right, so we're going to plot all of these points. The first point we found was the y-intercept, and that was 0, 0. And then our x-intercepts at 0, 4, and -6. And then we plot the turning points that we found in part C. Our first turning point was -4, 64. And then our second turning point was 2, -32. Now our graph needs to match the shape that we sketched in part part A, right here. So our graph should be starting down, coming up, maybe it has a couple of waves in the middle, but it should end in the positive direction. And when we look at our turning points and our zeros, that's exactly what our graph does.